Hello. I wanted to share in my week 11 reflection screencast number 2. This lab here, this optional lab, factors affecting electrical resistance. And I and a colleague did this lab similar to this, not with wire, but with Play-Doh. And the Play-Doh actually did a decent job because what he actually did in the class, I'm not there yet, is change the area, the cross-sectional area of the Play-Doh, the thickness of the tube of Play-Doh, and saw how resistance was affected and how current was affected with that. And he got a linear relationship. He also changed the length of the Play-Doh and found a linear relationship between resistance and the length of the Play-Doh. And then he looked here. He also did area versus resistance and found that that was an inverse relationship. So that as you increased area of the Play-Doh, made a thicker tube, then the resistance went down. But anyway, this equation was interesting because some of these thought experiment questions in the teacher's notes for this lab, they ask the students, for example, by what factor will rho or resistivity change when the length of the wire doubles? And the correct answer is no change. But that's not necessarily embodied in this equation. Rho equals resistance times area divided by length. So that if you double the length, you might think offhand, if there was no other changes, I guess, to resistance or area, then you would say that the resistivity would decrease if you increase the length. But as you increase the length, then the resistance also doubles. And so that causes no change. But in that equation itself, it's not implied that changing length changes resistance. And so, I guess the students would have to look for a correlation between length and resistance. And that's where they use their data from the linear relationship they found from the data collection where they were changing the length and seeing how resistance changed. But I guess I was just thinking, if the students saw this equation or I saw this equation by itself, it would not necessarily be true that if you increase length, you decrease resistance. As you increase length, you increase resistance. And that same goes with the area. Changing the area, it does not change the resistivity. So, for example, if I double the area, then that would have the resistance. And so there again, the area and resistance are related. And that, again, is borne out by the data collection that the students did. But I haven't done this with my students yet, but I think that they would still have problems with those questions because they wouldn't know where to look, I guess, to find that answer. And I don't know that they would be able to go back to their lab data and think through that. So anyway, and use that actually as, for answers to their questions. But it'll be interesting to see what becomes of that down the road.